There we go. Okay, so y'all, let's take a look at number 19 and see if we can't figure this guy out. It says, according to a recent study, the average length of a newborn baby is 18.3 inches with a standard deviation of 0.7 inch. Okay, so first thing I'm going to do here, y'all, I'm going to write down a couple of things. Our mu is 18.3, and our standard deviation is 0.7. Okay, and it says, can we complete parts A through C below and include a normal curve for each part? So look, y'all, part A says, what is the probability that a baby is going to have a length of 19 inches or more? So y'all, what we're looking for is what's the probability that X is going to be bigger than 19, okay? So y'all, the first thing we want to do, we want to convert this, y'all, to a Z-score. So if you remember, y'all, our formula for the Z-score was X minus mu over sigma, right? So our X here is 19 minus our mu, which is 18.3, and we're going to divide that by 0.7. So let me grab my calculator. Let me turn this guy on. Boom, here we go. And I'm going to enter it in, y'all. Actually, let me do this first. Minus 18.3 divided by 0.7. So y'all, one thing I want to mention, and this is my bad, I should have put this here. When you're doing that step, y'all, do that step in parentheses, especially on your calculator, y'all. Again, if you think about, like, remember when you were in 8th grade and you learned order of operations, like, please excuse my dear Aunt Salary or PEMDAS, we got to do what's in the parentheses first. So we want to do that subtraction, y'all, before we do the division. And if I don't put it in parentheses, it's going to divide 18.3 by 0.7, and then it's going to subtract that number from 19. And that's not what we want. So let's hit equals here. And y'all, I'm coming up with 1. That's what I'm coming up with. I'm coming up with the Z-score is equal to 1. So look, y'all, we're looking for the probability that Z is bigger than 1. Let me ask you a question. If you look at what I have right here, and we look at our 3 graphs for A, B, and C, which one looks like we're going to start at 1 and we're going to go to the right? A, right? So look, y'all, we're going to say, hey, look, you know what? Our answer is A. Now, how do we find this part here, y'all? Remember, we're going to go with our normal CDF, right? And we're starting at 1. And if we're going all the way to the right, wouldn't we say we're going to go all the way to 5,000? So we're going to go to second vars. We're going to go to number 2. We're going to start at 1, comma, 5,000, 1, 2, 3, hit enter. And y'all, they're asking me to round to 3 decimal places here. So if I'm going to go to 3 decimal places, everybody agree 0.159?
Yes.
All righty. Good, y'all.
That's so cool, sir.
Right? And then we got it.
I got different numbers and we got the same answer.
Same thing, right? Very good, very good. Okay, so look, y'all, let's take a look at part B. So in part B says, what's the probability that a baby is going to have a length of 19.6 inches or more? Okay, y'all, this is just like part A. We're going to say, what's the probability that X is bigger than or equal to 19.6? We're going to convert this to a Z-score. So we're going to go 19.6 minus 18.3 and divide it by 0.7. Okay. So look, y'all, I'm going to go parentheses 19.6 minus 18.3. Okay, and then we're going to divide that by 0.7. And y'all, I'm coming up with 1.857. Usually with our Z-scores, y'all, we normally go to like 2 decimal places. So I would say, what, 0.186? Okay, so look, we're going to say, what's the probability that Z is bigger than 1.86? Okay, so look, y'all, if I come back over here, and again, I'm going to just zoom in on my graphs, okay, so I can see this a little bit better. 1.86. if I look at my graphs, y'all, A, B, C, and D, which one looks like it's starting at about 1.86? So if it helps y'all, look, that's 3. So isn't that 1? Isn't that 2? That's 1, that's 2, that's 1, that's 2, that's 1, that's 2, right? Minus 1, minus 2, so on and so forth. Which one looks like it's about starting at 1.86? A, right? And you say, why A? Because look, it's right before 2. Okay. All righty. And now we're going to do the same thing, y'all. We're just going to go with our normal CDF. We're going to start at 1.86 and we're going to end at 5,000. So let's go second in VARs. Number 2, 1.86. Okay, comma. And we said we were going all the way to 5,000. There we go. Let's hit enter. And again, y'all, we're going to 3 decimal places. So I guess here I would say, what, 0.031? All right. Doing good so far, y'all. All right. And the last part, y'all, part C says, what's the probability that a baby's going to have a length between 17.5 and 19.1? So notice, y'all, I'm going to do this. Look, 17.5 and 19.1. Okay. So, y'all, when I'm doing something like this, remember, I'm going to find 2 z-scores. I'm going to call them z1 and I'm going to call them z2. Okay. So the first time, y'all, I'm going to use that x value. I'm going to go 17.5 minus, I believe our mu was 18.3. And we're going to divide it by 0.7. And the second time, we're going to use this guy. 19.1 minus 18.3 divided by 0.7, right? I don't need that other big parenthesis right there. Boom, there we go. Okay, so look, let's try that. So we can figure out what our 2 values are. So 17.5 minus 18.3. And I know I forgot parentheses, so I'm going to hit equals first. And then I'll divide it by 0.7. And y'all, I'm coming up with a negative 1.14. Okay. And then we'll do exactly the same thing here. So now we have 19.1, right? Minus, again, 18.3. And I know I forgot my parentheses again. So let's hit equals. And let's divide that by a 0.7. And I'm coming up with positive 1.14. Okay. All right. So now, y'all, let's take a look. What we're trying to figure out now is this. Which one of those 4 pictures up there, y'all, A, B, C, and D, if I just kind of take a look here, looks like we're starting off at a little bit to the left of -1 and a little bit to the right of +1. But remember, we're looking for the middle, right? So wouldn't it be B, right? Because right here, we're a little bit to the left of -1. So that is at negative 1.14. And that's the positive 1.14, right? And because we're looking in the middle, that's right. Now, if it would have said, what's the probability that it is not that, then I agree with you. Then we would have chosen C, right? Because we would have said, we don't want what's in the middle, we want what's on the outside. But very good. Okay, now, y'all, just like we did before, we're going to use, again, our calculator so we can figure out what is our normal CDF. Okay, and we're going to go from negative 1.14 to a positive 1.14, right? All right, so let's go right here. Second in VARs, número 2, negative 1.14, comma 1.14. Okay, and we hit equals. And again, y'all, if I'm going to 3 decimal places, guys, I'm coming up with about 0.746, I guess. All right, so 0.746, boom. And we got it. All right. So is this making sense, all, as we're going through it? Are we doing okay? Yeah?
We only have to do it once, sir, to get that, because if we do it again for the positive, it's still gonna give us the same p-value, correct? The 0.746.
I'm sorry, say that again.
So for the answer that you put there.
Uh-huh.
We only have to do it once, right? For the negative or the positive, whichever one we use will give us that area because it's right.
Remember, yeah, because I'm looking for the area in the middle between those, right? That's why I said from the lower level to the upper level, right? Because we want all the area, what, in there? That's the area we're looking for, right? Now, remember what I said. If I read the question, and I guys, to give you a heads up, remember, when you're taking your test, y'all, like if this question is on the test, it's going to be the exact same question, but with just different numbers, right? But had the question said, what would be the probability that a baby does not have or is not between these two numbers, then we would have been looking at this guy. And we would have done everything the same way. And once we found that area, we would have said 1 minus 0.746, and we would have found the probability that it was not, right? But that's basically all you're doing.
So what I was doing, sir, I was getting my negative, the 1.4, and then I would do negative 5,000. So I was getting the outer.
You were getting the outside, right? Yeah. We don't want the outside. We want the inside.
Exactly.
Yeah.
Thank you, sir.
You're welcome. You're welcome. All righty. So let's take a look-see here, y'all. For number 20, it says we're given the sample mean and a population standard deviation. Okay, it says use this information to construct both 90 and 95% confidence intervals for the population mean. Okay, let's do the 90% confidence interval. So y'all, there's a couple things I'm going to do here. My n in this case, y'all, is 55. Okay, our x bar, our mean price is 112, and our standard deviation is $19.90. 90 cents, sorry, not 99, but 90 cents. Boom, there we go. Okay, and we're going to do the 90% confidence interval. So y'all, when we first did this, again, I showed you how to do it by hand, right? But again, we're going to use the technology because it's going to make this so much easier. Let's go to tests, okay? Y'all, since we are looking for confidence intervals and we have our population standard deviation, we're going to go to number 7. We're going to go to the Z interval, okay? And we're going to enter in the stats, okay? So I'm going to go to stats. The first thing it's asking me, what is my sigma? Look, I wrote it down, so it's going to make it easy breezy cover girl for me to do. Look, it's 1990, okay? My X bar, look, I wrote it down, 112, okay? My N, look, I wrote it down. There it is. My confidence level, since we're looking for a 90%, y'all, that's going to be 0.90. We're going to go to calculate right here. We're going to hit enter. And we got this, and they're asking me to go to 2 decimal places, which is exactly what we have. So, y'all, I'm going to say 107.59. And the other one was 116.41. And you're done. And that's all you got to do, right? Okay, so now look, when we go to part B, which says, can we do the same thing, but can we make this a 90% confident or 95% confidence interval? Absolutely. Look, we're going to come back here. We're going to go to test. We're going to go to number 7. The only thing I'm going to change, my friends, right here, confidence level, 95%, change it to a 0.95, hit calculate. And again, they're asking me to go to 2 decimal places, which is exactly what we have. So I'm going to say this is 106.74. I believe that was the number. And 117.26. Okay. All right. So y'all, now they're asking me which one is, can we interpret the results? Okay. So y'all remember, we're always talking about, in these cases, we're always talking about population means. Okay. We're looking at population means. So when I look at this question, I already know that when I get to this third part, it's either going to be A or C. And the reason why I know it's going to be A or C is because this one is talking about sample means. That's not what we're talking about. We're always referring to population means. Okay, so when I start to look at this thing here, and if I look at the first sentence here and I look at the first sentence here, they're telling me exactly the same thing. And I look at this first sentence here and that first sentence there, it's still telling me exactly the same thing. We got to figure out the last sentence. Which one is wider, the 95% or the 90%? Anybody know which one is? Yeah, the 95% is wider, y'all. The bigger the the confidence level, the wider it's going to be. And y'all, I don't think I showed you guys this, but I remember doing this back in the day, the last time I taught this class. Look, I'm going to go right here. Look, 106 and 117. I'm using those numbers right now, right? Now, where would 107 be? Inside, right? Okay, so which one is bigger? Those, right? Because it's further out, right? It's like somebody's giving you a hug like this. Somebody's giving you a hug like that.
So when it talks about the first interval, is it talking that what you just
The 107.59, right? The 90% is the first interval,
Yeah.
and the 95% is the second one, right?
In my mind of thought, I thought it was talking about the margin of error.
Oh, yeah. All righty. Let's take a look here, y'all. So we're going to do the same thing here. It says, look, assume a random sample of 18 people. Okay, y'all, I'm going to stop real quick. N is 18. Has a mean commute time to work for 34.9 minutes. Okay. 34.9 is my sample mean. And our standard deviation was 7.2. Okay, so y'all, so the difference between 20 and 21 was in 20, they gave us the population standard deviation. They're giving us sigma. They're specifying that's the population one. When I look at 21, it just says standard deviation. That is the sample standard deviation, y'all. And in this case, it's 7.2. Okay, so the first thing we're going to do here, y'all, is we're going to see if we can find our confidence interval. Okay, look, guys, I'm going to come back here. I'm going to take my calculator. Let me clear this out. We're going to go to stat. We're going to go to tests. I'm going to scroll down, y'all, to my T interval test. Okay. And again, I'm going to enter in my stats. Okay, let's see. The first thing it's asking for is my X bar. My friends, I wrote that down so that it would be easy breezy cover girl for me to do. Okay. The next thing it's asking for is my S. We wrote that down so that it's going to be easy breezy cover girl for us to do. Our N, since we wrote that down, I can just enter this thing in. And we're looking for a confidence interval of what, 90%? So I'm going to scroll down here and I'm going to put a 0.90 because that would be 90%. We're going to calculate it. Okay, here we go. So y'all, I'm going to see how many decimal places they're looking for. They're actually looking for just one decimal place. So y'all, for the first one, I would say this is going to be 31.9. And for the second one, I would say that's going to be 37.9. Okay. All right. So it says, assume the population is normally distributed, use a T distribution, which is what we did. Okay, now they want us to find the margin of error. Okay, so y'all, if we're looking for the margin of error, to give you an idea, like visually, what is going on when we do our confidence interval here, the way we're finding those numbers, y'all, that is X minus the error, and this is X bar plus the error, right? We already know what our X bar is, y'all. It is 34.9. Okay, so we wanted to find the error. We could pick which one of those two do we want to use. It doesn't really matter. I'm going to pick this guy right here. Okay, so look, y'all, 37.9 minus 34.9, that's going to give me what my error is. So if I subtract that, that's going to give me a confidence or margin of error of 3. Okay. Okay, again, y'all, anytime we're doing confidence intervals, we are always referring, my friends, to population means. Okay. So look at part A. With 90% confidence, it can be said that the population commute time is between the bounds of the confidence interval. So y'all, I'm going to choose A. Let me go down a little bit further. Okay, let's take a look-see here. Let's see. Y'all, look at part 22. It says, let P be the population proportion for the following condition. Find the point estimates for P and Q. Okay, it says, in a survey about 1,139 adults from country A, 258 said they were not confident the food they eat is safe. All right. So let's see. Let's see if we can find our p hat. Remember, y'all, the way we're going to find our p hat is we need to know our x, sorry, and we need to know our n. N is the number of adults total. So in this case, my n is 1139. Okay. X is the number who responded to the survey saying whatever it is that they said. And they said, you know what? I don't think the food in this country is safe. There was, what, 258 of them? So my p hat, y'all, is going to be 258 divided by 1139, right? So y'all, I'm just going to grab my calculator and I'm going to say 258 divided by 1139. And y'all, they are asking me to go here to 3 decimal places. So I guess here, y'all, I would say 0.227. Okay. And now, y'all, it's been a minute since we did this part, but look, now we're trying to find the point estimate for Q hat. Y'all, there's a couple of ways we can do this. I think the easiest way to do this, y'all, P hat and Q hat have to add up to 1. So the way you can find Q hat is you can go 1 minus P hat. Okay. So look, y'all, I'm just right here. I'm just going to go 1 minus 0.227. And I'm going to hit enter. And I'm coming up with 0.773. Right. The other way we could have done it, y'all, and again, you're still going to get the same answers. You can say, look, we had 1139, right? How many of them said that they felt like the food was not safe? 258. Let's take away those 258. How many are we left with? 881 out of the 1139. And I'm still getting 0.773, right? Either way, you can do it. This is probably the easier calculation to do, but that's really all you're saying.
Like that.
Okay, let's see if we can figure out number 23, y'all. So 23, let's see what it says here. It says, in a survey of 2,027 adults in a recent year, I'm going to stop right there, my friends, because that is my N, right? My N is 2,027. Out of those 2,027, 714 of them said, you know what? This is my year, right? No more McDonald's, right? No more Jack in the Box, right? Puro siempre natural, right? We're going to try to live healthier. Okay, we want to find both 90% and 95% confidence intervals, okay? Y'all, it's going to be very similar, right? Let's come back here. Let's grab our calculator. Let's go to stat. Let's go to test. We're going to scroll down to, let me see if I can find it. I'm trying to remember where it is. Here we go. Choice A, y'all. We want to do a 1 proportional Z interval, okay? So I'm going to click here, right here. All right, look, first thing is ask me, what's my X? Look, y'all, I wrote it down because it makes it easy breezy cover girl for me to do. What's my N? Oh, mira nomás. I wrote it down because it makes it easy breezy cover girl for me to do. The first time we want a 90% confidence interval, we are already there. By default, that's what it had. Okay, now, y'all, they're asking me to go to 3 decimal places. So for my first one, y'all, I'm coming up with 0.335. And for my second one, I'm coming up with, I guess, 0.370. Okay. All right. Now, we're going to do the same thing, y'all, but we're going to change this now from 90% to 95, right? So look, let's do the same thing. Let's go to stat. Let's go to test. Let's scroll all the way down, Charlie Brown, to choice A, our 1 proportional Z interval. Okay. The only thing I'm changing here, my friends, is making that into a 0.95, right? Let's go hit calculate. Let's hit enter. And again, y'all, I'm still going to 3 decimal places, so I'm going to write 0.331 and 0.373. Okay. So now, when I get to the next part, y'all, what it's asking me to kind of fill in the blanks here. I want you to notice something here, y'all, because sometimes my students say, sir, I'm always confused. What are they asking me to do? Look what we're talking about, y'all. We're talking about population proportions. So look, when I'm doing this, y'all, again, because I printed this out, right, it's going to give me an option. Do I want population proportion or sample? Hey, we're talking about population. So let's put the population there. Is going to be between the endpoints, right? So right here, we're going to say between the endpoints, right? So, and y'all, just to kind of give you an idea, what is this really telling me? 33% and 37%, right? Between 33 and 37%, that's going to be our number right there, right? All right. So let's keep scrolling down. We are on number 24, y'all. Okay, so let's take a look, y'all. This is when we start talking about our hypothesis testing. So remember, y'all, we're going to be looking for things like the hoe and the ha, all that kind of good stuff, okay? So look, let's see if we can figure this out. It says, for the statement below, write the claim as a mathematical statement. Use proportions to state both the null and alternative hypothesis. So it says, according to a recent survey, 70% of college students used student loans to pay for college. Okay. 70% is equal to 0.70. So y'all, if I write this down right here, and then I look at my choices, wouldn't you guys agree that's going to be choice C? Okay. All right. So look, y'all, this here is also our claim, right? Wouldn't that here, y'all, be the hoe?
Mhm.
So then the ha is going to say that P
It's not equal.
is not equal to. Very good. Look, y'all. So right here, I'm just going to kind of show you. See how like, here we go. Let me zoom out a little bit just so you can see what I got. So y'all, you can look here. If I look at my choice number one, right, it's equal to, right? So it's going to give me one of those, but we're going to put an equal to here. We're going to put a not equal to here, right? And then we're going to say, okay, which one is the claim? The null hypothesis, the hoe is the claim, right? So look, y'all, wouldn't that be choice C? That is the claim because we had an equals there, right? Because sometimes people say, Omar, how did you know it was not D or E? Because ours had an equal sign. And if you look at D and E, they have either a greater than or equal to or less than or equal to, right? That was our claim. All right, so let me keep moving down the list. And let's see if we can figure out this one. So look, y'all, we got 25. Fast food restaurant estimates that the mean sodium content in one of its breakfast sandwiches is no more than 925 milligrams. Okay, so we're talking about the mean. So y'all, I'm going to use the little funny looking U letter, right? No more than 929. That means that is the biggest number it could be, right? So it's going to be 929 or less, right? Okay, this here is my claim. Okay, y'all, because we have an equal to this little equal to part, that's my hope. So then bigger than 929 is going to be my ha. Okay. So now let's take a look. Let's see if we can figure out which of the choices A through F matches what I wrote right there. Would you guys say B? Does it look like B is what we wrote right here? The hoe is mu is smaller than equal to 929, and the ha is it's bigger. So that looks like that's what we wrote right there, right? Okay, now, y'all remember we need to find our critical value. So look, y'all, I'm going to do this. I'm going to draw my normal curve. Okay. What we have to determine now, my friends, is this going to be a left tail, right tail, or two-tailed test? And we always look at the ha. Which way is my arrow pointing? To the right. Very good. So look, y'all, that is where my area is. My area is my alpha. So that's 0.05 right there, right? So y'all, remember what we're trying to do is we're trying to find the Z value that's going to go here. Now, y'all, if I'm using my calculator, remember my calculator is always going to tell me the area to the left. It's going to tell me I need to know that area. That area, y'all, would be 0.95 because it has to add up to 1, right? So look, I'm going to come back here, my friends, turn on my calculator. Let me clear it out. We're going to go second vars, right? We're going to go to number 3. We're going to find our inverse norm. Again, my area to the left is a 0.95. My Z value, guys, should be a positive number because look, it's all the way over here on the right side, 1.64. That is my critical value. Okay, just as a reminder, y'all, that's my rejection region. This is our fail to reject region, right? So look where the rejection region is. It's to the right. So choice C, okay? Choice C. Okay, now let's see if we can do part C. We want to figure out the standardized test stat. It's telling me to use technology. Okay, before I go through all that stuff, y'all, I didn't even finish reading my question. So let's come back over here. A random sample of 44. So N is 44. My X bar is 924. My population standard deviation is 21. Okay, so I'm writing those things down, y'all, because that's the info that they're giving me, okay? So look, y'all, I'm going to come back to my calculator. I'm going to clear everything out. I'm going to go to stat. I'm going to scroll over to test. We, my friends, are doing our Z test, right? So let's come back here. We're going to enter in our stats. Okay, what's my mu? My mu was 929, right? Boom. Okay, what is my sigma? Oh, 21. Why? Because I wrote it down, right? What's my X bar? 924. Okay. What is my N in this case? Oh, look, it's 44. Okay. And then the next thing is, did we have a left tail, right tail, or two tail test? We had a right tail test, right? So look, y'all, I'm going to go to this guy over here. I'm going to click enter right there. We're going to calculate. We're going to click that right there. And we found our Z-score, my friends. In our case, my Z-score, y'all, I think they're asking me to go to 2 decimal places. This looks like it's going to be a negative 1.58. Okay. So look, y'all, negative 1.58 would fall somewhere right over here. We fell in our fail to reject region. Okay. So now, my friends, when I get to the last part, which is choosing A, B, C, or D, I already know because I fell in my fail to reject region, we can choose either A or D, right? Now, which is the one I got to choose? Y'all, I'm going to come back here real quick. Sorry. Let me come back this way. I'm going to grab my formula sheet for test 3 because this has the info that I need. So look, y'all, I'm looking at this part right here. I want to figure out which one was my claim, right? So if I come back here, y'all, and I said, look, my claim was the hoe, and we fell in the fail to reject region. So look, if our claim is a hoe and we fell in the fail to reject region, we're going to say there is not enough evidence to reject the claim. So I'm going to say there is not enough evidence to reject the claim. So we're going to pick choice D as in dog. And we're done, right? Y'all, I know it's a lot. Y'all, chapter 7 is like what I always say about stats. Chapter 7 is like the big chapter, right? This is where all the stuff kind of comes into play. And there are, well, it sounds like it's raining. There are a few steps involved. I'm not going to lie to you and pretend like it isn't. But what I want to show you is that if I just go through step at a time, I can figure it out. Y'all, like I said, one thing I want to remind everybody of, y'all, when you take your final, you have 5 hours to do it. Okay. I'm not putting 5 hours because I expect it's going to take you 4 hours to do. I really don't. I think you'd probably do it in like an hour and a half, maybe 2 hours at the most, right? But I put those 5 hours because I don't want you to worry about time. I don't want you to be, guys, let me ask you a question. In any of your other classes, do you all have to take tests in class? You do? In your class? In some of your classes, you do? When you're taking your test, does this ever happen to you? You're there taking your test and all of a sudden your stomach starts making all these noises because you're nervous. Y'all, one of my professors that I had it was UTP at the time. I just found out today he's retiring. He was still working, right? When I got there, he was pretty, new. Wow, that's really coming down. But he's retiring. But I remember the first class I took with him was this class called linear algebra. And y'all, it didn't matter if I ate before the test, if I didn't eat, it didn't matter. I'd be there taking the test. Man, my stomach was in why because I was nervous, right? I was just nervous, not because I couldn't do the material, right? I could. I passed the class. I think I got a B or something like that. But it's just part of human nature, right? I'm trying to eliminate that factor for you guys. So y'all, when you're doing this, I guess the point that I'm trying to make is take your time. I'd rather you be the last person to finish. And then when you hit submit, it's like a grade that you want to see. Now, what grade is that? Well, that depends on what you want to see. If you're cool with a 72, then I'm cool with you making a 72. But if you're like, you know what, I want to get a 90 or better, that's what I want for you too. But I don't want you to have to fret about time, okay? All right, let's take a look, y'all. Wow, it's raining pretty hard. Okay, let's take a look at the next question. This is number 26. And it says, a credit card company claims that the mean credit debt for individuals is greater than 530. Okay, so first thing I'm going to do, y'all, the mean is greater than, 5,300. This is our claim. That is my high. This is the hope. Okay. All right. So it says write the claim mathematically and identify the ho and the ha. We have it right here. So let's take a look and let's see if we can't figure out what we got going on. Let's see. Y'all, if I'm looking at these things here, what, choice D, I guess? Looks like this is what we wrote here. The ha is bigger than 530, and the ho is less than or equal to. That's what we have there. Okay, now, next thing we got to figure out, y'all, we got to figure out whoa. Okay, guys, I'm going to stop real quick because I don't know. We might have lost internet. Let's see. Let me just double check. Let's see. I think we're still good, actually. Okay. I think we're still good. Natalie, I think you're still with us. Are we still good? Are you still with us? I don't know if you can hear me or not. But I think we're still good. Let's see. I think there's something here in the chat. Okay, we're still good. Yeah. Awesome. Okay. We just had a little power flicker, so I wanted to make sure we're still good. Okay, so y'all, next thing we got to figure out are where are our critical values so we can find our rejection region, all that kind of good stuff. Okay, here's my normal curve. Y'all remember, the ha tells me what we're looking at. We're looking at a right tail test again. Okay, alpha in this case, y'all, is a 0.05. So remember, y'all, what we're going to do now is when we start to find our critical value, the first thing I want you to know, they're giving me that T there. Okay, so y'all, if they're giving me that T there, this is going to be, I'm going to have to use my inverse T. So look, y'all, the area to the left is 0.95. Y'all, on your calculator, you're going to go inverse T, 0.95, and then remember, we have to do something called the degrees freedom, right? So in this case, y'all, my N is 35. So if you remember, y'all, my degrees freedom, always one less, 34, okay? So guys, I'm going to do this because on my calculator, I don't have the inverse T. So look, let me come back here and inverse T calculator. I think that's what I looked up the last time. Let's try this guy here. I think that might have been the one that we used. Oh no, that's not the one that I used. Which one was it? 1.691. Okay, thank you. That makes it so much easier. 1.691. We won 3 decimal places. I appreciate that. There we go. Okay, so look, y'all, this number right here, thank you so much. 1.691. Remember, y'all, that's my rejection region. I'm going to do this in green. This is my fail to reject region. Okay, so look, because the rejection region is to the right, 1.691, right to the right of it. Okie dokie.
Sir, is there another way that, like, what if we didn't have that T to know it's a T? How are we gonna
Okay, how do you know that? Because see right here when it just says standard deviation, If it doesn't say population, it's going to be your sample standard deviation. And that's how you know, right? And the problem before they gave me, it said population standard deviation. That's right. You're welcome. You're welcome. Okay, so look, y'all, we already know our N. Okay, let's see. My mean credit, my X bar here, y'all, is 5586. And my sample standard deviation is 550. Okay, so y'all, I need that info because I'm going to come back to my calculator. Let's turn this guy on. Let's clear it out. Let's go to stat. Let's go to test. And we're going to do number 2, a t-test. Okay, so look, in this case, y'all, my mu was 5,300. Let's change this guy to a 5,300. Okay, my X bar is a 5586. Okay, our S appears to be a 550. Okay, our N, we wrote it down, was a 35. We're still looking at a right tail test, y'all. Okay, so let's hit calculate. Okay, and my T value, guys, I'm coming up with a 3.08. They want me to go to 2 decimal places, so 3.08 is what I'm getting. Okay, so look, y'all, 3.08 is actually over there. We are in the rejection region, right? Okay, so we fell in the rejection region, so we're going to reject the null hypothesis because we're in our rejection region. Okay, now we got to figure out, okay, what does all this stuff mean? Look, guys, I'm going to come back to my little formula sheet, boom, right here. My claim was the Ha, and we fell in the rejection region. So we're going to say there is enough evidence to support the claim. So we're going to say at 5% level of confidence, there is sufficient evidence to support the claim, choice A, and we are done.
Question, sir. Whenever we do the standard deviation, we cannot use the P to see if the P is greater than the.
You can do it that way too, but it just depends on the way the question is written,
Oh, you
right?
did both?
Yeah, they're both two valid ways to do it.
I did it the Z and then I did it the T, and it doesn't change. It stays the same. But when you do the P's, it changes by 100.
But so do it like this. So look, if you're going to do the P, remember if P is smaller than alpha, we reject it, right? So in this case, look what our P was, 0.002, right?
Yeah.
Our alpha in this case was 0.05,
Yeah.
right? So isn't P smaller than alpha,
Of course.
right? So if it's smaller than alpha, then what are we going to say? We're going to reject it, right? And then you still use this part here to do whatever you got to do.
Question, sir. Why does it still stay the same? Like, go back to the calculator.
Uh-huh.
And then so see how your T is 307.
Yeah.
When if you do it Z, it stays the same. But your P, you know how it's
Yeah, because remember, we're doing a T test. We're not doing a Z test, right? Because I have to know which test I'm doing based on this standard deviation they give me. If it just says standard deviation, it's a T test. If they tell me, let me scroll back up here. Yes. If they tell me population standard deviation, this is a Z test. It's a different test, right? Because I have different values. Those values mean different things. Okay, so look, y'all, I think we got 2 more to do. So let's see if we can't figure this one out. Okay, so y'all, let's see if we can knock this part out here. It says a research center claims that at least 28% of adults in a certain country thinks that their taxes will be audited. Okay, so look, y'all, at least 28%, bigger than or equal to 0.28. Okay, this is my claim. This is also our hope. So the Ha is going to say that P is smaller than 0.28, okay? So look, y'all, for the first part, it's actually pretty straightforward. At least 28%. Right here, I'm going to choose choice C, at least 28%. It's already written there for me. Okay, now when I get to the second part, this is exactly why I'm writing this stuff. Take a look. This is the hope. I'm looking for the hope that's going to say P is bigger than or equal to. That is choice D. Sorry, it's supposed to be an 8. There we go. P is bigger than or equal to 0.28 for the ho, and P is smaller than 0.28 for the Ha. Okay. Now, Next thing we're going to do here, y'all, we need to figure out what are our critical values. Okay, so let's come back here. Let's do this. Okay, our alpha in this case, y'all, is 0.10. Okay, now I got to figure out am I looking at a left tail, right tail, or two tail test? Looking at a left tail test. Boom, 0.10. Okay. So y'all, anytime we're doing this proportion type stuff, we're always going to use the inverse vars. Okay, so second vars, we're going to go here, number 3, inverse norm. We're going to say 0.10. We should get a negative value for z. Okay, negative 1.28. Okay, so again, y'all, that's my rejection region. This is my fail to reject. Okay, so I'm coming up with negative 1.28. Okay, the rejection region is when we are smaller than 1.28. Okay, now let's see if we can find a couple other things. I'm going to scroll back up here, y'all, because I got to find some other information. Random sample is 600. N is 600. Okay, 23%. So my p hat is 0.23. Okay, so let's see if we can figure this thing out. Y'all, I'm going to come back to my calculator and clear it out. Okay, I'm going to go to stat. I'm going to go to test. Y'all, we're looking for a one proportional z test, which is my number 5 here. Okay, first thing it's asking me for is my p-value. Look, y'all, my p-value was a 0.28. So let's put a 0.28 here. Boom. Now, it's asking me for my x value. Guys, I don't have my x value, but you know what? We can find it real quick. Let me do this. Let me get out of here real quick. How do I find my x value? I'm going to take 600, and I'm going to multiply it by the percentage that we had here for my p hat, 0.23. Okay. My x value, y'all, is 138. Okay. So look, let's scroll back one more time. Let's go back to stat. Let's go to test. Let's go to number 5. Okay, we got that there. Okay, my x value now is 138. Okay, our n number was 600. Okay, and y'all, we are looking at what, left tail test? So I'm going to click this second one, boom, right here. All right, let's go to calculate. Boom. Okay, let's see what our z value is. Y'all, my z value, according to this, I'm coming up with a negative 2.73. Okay. Are you using the one proportional z test?
Number 5, right?
Number 5. Okay, take a look, y'all. Give me 1 second, and I'll help you. Look, y'all, look at see how my p hat is 0.23? Check it out. That's the number we had, right? Okay, so look, y'all, we're coming up with a negative 2.73. That number, y'all, is over there. We fell in the rejection region, right? So what are we going to do? We're going to reject the null hypothesis. Okay, now let's figure out what am I going to put for my next 2 parts. Okay, let me scroll back down again. My claim was my hoe. Okay, let's come back here. The claim was the hoe, and we're rejecting. So we're going to say there is enough evidence to reject the claim. So we're going to say there is enough evidence to reject the claim. Did it work?
Yes,
You got it?
because I didn't put the decimal.
There you go. And you got it. Okay. So y'all, last question. Don't be sad because this is the last problem I'm going to teach you in this class. Let's take a look-see here. Number 28, it says, according to a publication, 12.1% of 18 to 25-year-olds were users of marijuana in the year 2000. Okay, let's take a look. Before you guys were even born. All right, my p hat. So look, y'all, we're going to say, I'm sorry, my p. It's saying 12.1%. Okay, this is our ho. So our ha is that it's not equal to, actually, let me do it this way. Boom, put our decimal, boom, right there. Let's get rid of the percent sign. Here we go. Okay, so the ho is that p is equal to 0.121, this is my claim, y'all. Okay, so right here, guys, I'm going to put 0.121 and that this is not equal to 0.121. Okay. All right, y'all, for this part here, they're actually asking me to find the test statistic first. So let's go ahead and find the test statistic. Okay, let's think about it this way. In a recent poll, so N is 1396, okay, randomly selected adults. We said that X, which was 193, we're currently smoking the devil's lettuce, right? Let's see if we can figure out what we got here. Okay, let's see if we can find our Z value. So look, y'all, let's come back here. We're going to do the same thing we did before. Let me clear this. Let me go to stat. Let me go to test. Let me go to number 5. Okay, so in our case, y'all, our P is 0.121. Okay, my X is 193. Okay, my N is 1396. Okay, y'all, I got to figure out, hey, is this left tail, right tail, or two-tail test? We should actually have a two-tail test, right? Because of the not equal to. So let me go down here. We're going to select that guy. We're going to calculate this. Okay, so y'all, I'm coming up with a Z value of 1.98. 1.98. Okay, now let's see if we can find our rejection and fail to reject regions. Okay, so y'all, we're looking at a two-tailed test, right? Remember, this is fail to reject. These are going to be the rejection regions. We're trying to find those two numbers. Okay, let's take a look at the percent they give us. They give us 1%. As a decimal, y'all, that's 0.01. But remember, we got to cut it in half, 0.005. Okay, let's find those two critical values. Okay, so look, y'all, I'm going to do this. I'm going to clear this out. I'm going to go second bars. We're going to go to an inverse norm. I'm looking for the area to the left, 0.005. Close it off, hit equals. Y'all, I'm coming up with a negative 2.56. And then remember, that one's going to be positive 2.56, right? Okay, so look, y'all, when we get to number 2, we're going to select, because we got two values, we're going to put that there, and we're going to put 2.56. Okay, let's take a look at the number that we came up with. When we did our test statistic, y'all, we came up 1.98. We fell in the fail to reject. So we're not going to reject, right? I'm either going to choose choice A or choice C, because those are my do not rejects, okay? Now, I'm going to come back one more time, y'all. Look, my claim was my hoe, right? So look, if my claim was my hoe and we're failing to reject, we're going to say there is not enough evidence to reject the claim. So we're going to say there is not enough evidence to reject the claim. And then we're done. All righty. So y'all, let me do this real quick. Let me stop the recording. Let's go like that. Stop it.